I will talk about today is joint work with Julian Schmid, who is getting his PhD at the Max Planck and at the Freie Universität Berlin. In our project, we study the net replacement rate which is needed to maintain the living standard achieved during working life in retirement, where net replacement rate means net retirement income divided by net pre-retirement income. So that's just a simple ratio. What does this mean? Well, you all right now have a certain income and you can achieve a certain living standard with it. Now imagine that you would retire tomorrow. How much income would you need to keep your living standard constant? Could be that you need less income because you don't have any more work-related expenses, you don't need to commute to work anymore, you don't need to save for retirement anymore. Could also be that you need more money because you have more free time and you need to do something with that, you want to travel, whatever. And could be that, for instance, the net replacement rate needs to be 90% for you so that you keep your living standard constant, meaning that you would need 90% of your pre-retirement income for this constant living standard. We propose to use this as a standard for pension adequacy, and most importantly, we present methods to estimate this. And applying these methods, we find that in the US, England, and Germany, the adequate replacement rate is around 100%, plus minus 10%. There's some uncertainty to this, but we'll see this later. Now, why study this? I guess you all know that there is pressure on social security systems in general and pension systems in particular in many developed countries due to population aging caused by low fertility and increasing life expectancy. The proportion of the population aged 65 and older is increasing, meaning that the ratio of people receiving pensions to people contributing to pension systems is shifting, and at the individual level, increasing life expectancy means that pension provisions need to last longer. All these things raise the question of sustainability of public finances. Much has been written about that, and here the question essentially is, what level of pensions can we afford? And we study a related question: what level of pensions do people actually need? So we are interested in financial security of pensioners and whether pensions are adequate. Now, what does adequacy mean in this context? What are adequate pensions? Surprisingly, there is no clear benchmark in the literature, so you will find many documents from the European Union, for instance, talking about pension adequacy, but never properly defining that. And there's some literature out there which looks at related things but never really pension adequacy. For instance, there are life cycle models, which are a big thing in economics. These models essentially study the complete life cycle. Sociologists would say life course. And during your life course, you go working, and then you can consume and save. At some point, you retire and need to live off your savings. Now, given some assumptions about utility functions and smoothing of marginal consumption, some technical things, you can estimate these models, and these models then imply certain levels of replacement rates. But these replacement rates are optimal saving replacement rates. Optimal saving does not necessarily imply adequacy, or the other way around, adequate replacement rates might not be optimal in some sense. Another idea are minimum standards, which look at poverty thresholds. And then the idea is, okay, what is the replacement rate you need to have to be above a poverty threshold? And of course, being above a poverty threshold is kind of a minimum requirement for a pension to be adequate. I guess we can all agree on that. But having barely more than the poverty threshold likely is not adequate in itself. And for the other things listed here, it's the same. All these concepts, all these ideas are very useful, are very interesting, but they don't study adequacy per se. And that's where our framework comes in. As already said, we want to use replacement rates simply because they're a very convenient way of measuring the level of pensions. And we use net replacement rates based on net income. We could also use gross replacement rates. Both have well, some pros and cons. And then we say, okay, we propose as a benchmark for pension adequacy the level of the net replacement rate, which allows to maintain the living standard achieved during working life in retirement. So the net replacement rate, which allows a constant living standard. We think this is a pretty useful idea because it's easy to understand. You all have an idea of your living standard right now and what it would mean to keep that constant. In some countries, policy debates about levels of pensions are framed in terms of a constant living standard. For instance, in Germany, where there is this idea that pensioners should not be worse off than working people, or at least not too much. And as it turns out, our empirical results show that this constant living standard net replacement rate is close to what individuals would prefer as a replacement rate. To fix ideas a little, we can write down everything like, well, economists would do. R is the replacement rate. Z0 are social demographic characteristics before retirement. Z1 characteristics during retirement. U is the utility level. P are prices. So the replacement rate depends on some things, and on the right-hand side we have I, which is the income function defined via the indirect utility function. The income function essentially gives the income level, the smallest income, which allows you to achieve utility level U, given some social demographic characteristics and prices. So here this ratio is simply the ratio of income needed to achieve utility level U during retirement. In the numerator and in the denominator, the income needed to achieve this utility level before retirement. And writing things down like this is, I think, very helpful, because it makes very clear that here we are comparing two situations: before retirement, in retirement, in contrast to other things which people have been doing in the literature, like, for instance, life cycle models, which look at the complete life cycle, the complete life course. This net replacement rate is very similar in structure to equivalence scales. Equivalence scales are used to compare households of different type. So, for instance, a childless couple with a couple with one child, and then the question is, how much more does the couple with one child need? Maybe some of you have heard of or used the modified OECD scale. It's an equivalence scale. And there's a huge literature on equivalence scales, how to estimate them, which problems there are, and that helps us a lot when estimating replacement rates, so we can build on this literature. The definition also shows that replacement rates, adequate replacement rates, are potentially price dependent, and that they are potentially utility dependent, meaning that people who are well off might have a different replacement rate than people who are not so well off. Now, in what follows, we will simplify things quite a bit and will assume that replacement rates do not depend on prices. We assume a fixed price regime. We will assume that replacement rates do not depend on the utility level, which is a testable assumption, and I will actually come back to that. and there will be one or two exceptions to this, where we indeed assume that replacement rates depend on the utility level, but for now we will assume that they don't. And we assume that replacement rates, adequate replacement rates, do not depend on any covariates, like for instance age or health or whatever. And that's not a necessary assumption. We can estimate replacement rates by age or health or whatever, but I'm just not focusing on this in this presentation. Now that we have more or less well-defined theoretical framework, the question is, how can we estimate this? And to do this, we make use of the counterfactual framework, which some of you may know. Here in our case, this essentially means that we have a retirement indicator, which can be 1, meaning retired, or 0 otherwise. We have WD, which is the welfare level achieved during retirement, which would be W1, or before retirement, which is W0. And we have the YD, which is a function of W. That's the income level needed to achieve a certain welfare level during or before retirement. Now, for a given individual, we either observe W0, Y0, or W1, Y1, never both. So we either observe you in retirement or before retirement. You cannot be retired and not retired at the same time, obviously. Which makes estimation of adequate replacement rates not very straightforward, because using this notation, adequate replacement rates look like this. Y1 given W0 and Y0 given W0. So the income needed in retirement to achieve the welfare level or living standard you had before retirement, divided by the income needed for this welfare level before retirement. We just do not observe this quantity for single individuals. But as it turns out, we can still estimate it. If we take the expectation of the individual replacement rate with some simple algebra, it turns out that this is equal to this here on the right-hand side. So some simple expectations and a covariance term. Now, given standard assumptions, the expectations are identified. The covariance term is only set identified, not point identified. And this covariance term captures income dependence. Now first, what does standard assumptions mean? Standard assumptions are unconfoundedness, overlap, and stable unit treatment value assignment. Here in our application, unconfoundedness essentially means that there is no selection into retirement depending on your individual replacement rate. Say that people who can expect a high replacement rate retire earlier, for instance. Overlap means several things actually, but most importantly, that the welfare levels which we observe before retirement and during retirement are the same. This does not mean that the welfare level cannot change for individuals, or that we need the same proportion of people who are, say, well off. But if before retirement there are people who are, let's say, very well off, then we also need at least some people who are very well off during retirement. And stable unit treatment value assignment means that whether an individual is retired or not does not depend on the retirement of other persons. So if you are retired or not does not depend on whether I'm retired or not. So these are the standard assumptions, and given these assumptions, as I said, the expectations can be very easily calculated. That's straightforward. What's problematic is this covariance term here, which is only set identified, which means that we only can say that this covariance is in a certain range. It's between values A and B. It's not point identified, which would mean that we can just calculate a single number for it. And as I said, this term captures income dependence. If you look at it, this is a covariance of the replacement rate with pre-retirement income. If this covariance would be, say, negative, this would mean that the replacement rate is lower the higher your pre-retirement income is. So that could be the case if, for instance, people with a low income need a relatively high replacement rate. They are already relatively poor, they just cannot do with any less money. Whereas people with a high income, before retirement, they might be spending quite a lot already on pension savings or something like that, so they can do with less in relative terms. So then this covariance would be negative. And yes, so this is something which is not very straightforward to calculate. And to make things easier, we first assume that we have some measurement or a good proxy of the welfare level captured in one single variable, W. So we have one single number which tells us how well are you off. And this must be something different than, of course, income. This needs to be something which is comparable before and after retirement. Given this, so the approach is very general. We just need some measurement of W, can be anything which we think is reasonable. And then we can use either a parametric approach or a semi-parametric approach or a non-parametric approach. We apply all of these three approaches because, well, the parametric approach is super straightforward. It's very easy to apply. We will see that in a second, but it has very restrictive assumptions. The non-parametric approach, on the other hand, is very difficult to apply. It's only partially identified, but it's not restrictive, at least not as restrictive regarding the assumptions as the parametric approach. And the semi-parametric approach is somewhere in between. And to some extent we can test these assumptions using the different approaches. And when we apply all approaches, and we can see, okay, are these assumptions of the parametric approach justified or not? And we will see that in a bit. Now let's look at the parametric approach as just one example. I won't talk about the semi-parametric approach and the non-parametric approach in any detail because they are quite a bit more complicated. But the parametric approach simply is a linear regression approach. What we do is we have a linear regression with the welfare indicator as a dependent variable, and then on the right-hand side we have log income, the retirement dummy, and potentially some more explanatory variables. Can use, for instance, age, gender, education, whatever we like. And then, given some assumptions, one can show that the adequate replacement rate simply is the ratio of two coefficients, the coefficient of the retirement dummy and the income coefficient. And this ratio, we take the exponential essentially. Now, this only works if there is no income dependence, meaning that the covariance term, which we just saw, is 0, right? So everybody has the same level of the replacement rate. Only given this assumption, this approach works. And the non-parametric approach does not use this assumption, whether the covariance is 0 or not. and we can test whether the covariance is 0 or not if we use the non-parametric approach. Now, given these three approaches, we looked at data for 3 countries, the US, England, and Germany. So yes, we used the health and retirement study. For England, we used ELSA, and for Germany, the income and expenditure survey. As our identification strategy does not require longitudinal data, we just looked at the last waves available. We analyzed each data set separately, and for each data set we only looked at individuals aged 60 to 69. We did this because in this age range we have both retired people and non-retired people. That is essentially to fulfill the overlap condition, so that the retired people and the non-retired people are at least somewhat comparable when we calculate replacement rates. We only look at individuals living alone, and there are several reasons for that. One is a more theoretical reason. The framework which I presented is based on working with utility functions, and utility functions are only well defined for single individuals. If we would look at, say, couples and look at households of couples, we would need to introduce household utility functions, which is very problematic from a theoretical perspective. So that's why we would like to avoid that. Only looking at individuals living alone also makes identification of retired households a bit easier. So single persons, we can just say, okay, is this person retired, yes or no? If we look at couples, it could be that one person is retired, the other not, and then the question is, okay, how to treat this household? So we don't have that problem, and also the sample might be a bit more homogeneous with respect to bequest motives. What we also did, we excluded some outliers and some individuals with low and high incomes. That's not too important. And the variables which we used as income concept, we used monthly net income plus annuitized wealth, including housing. The welfare level is measured through the income share of expenditure for food at home, which is pretty standard in the life cycle literature, but I will come back to that in a second or a minute. Retirement, for the German data and the English data, we used self-reported retirement status. For the HRS, we used the rent variable, so a generated variable which combines several variables of the HRS. And in all cases, we added or we checked whether individuals worked more than 20 hours per week. And then we also control for some additional variables like age, ethnicity in the US, gender, education, whether the individual is divorced or not, whether the individual is a homeowner or not. Then we controlled for the region, whether it's a rural region, a metropolitan region, or something in between. And for Germany, we included a dummy variable for East and West Germany. And this is what we find. So at the top we see results for the HRS, in the middle for ELSA, and at the bottom for Germany. The vertical gray line shows a replacement rate, adequate replacement rate of 100%. So that's the level where pre-retirement income and retirement income are the same. Would need to be the same to keep the living standard constant. The dots show the parametric estimates, the squares show the semi-parametric estimates, and the brackets are the identification bounds as I said, estimates of the non-parametric approach. For ELSA, we don't see a square because there were some convergence issues with the semi-parametric approach, likely due to the very small sample size which we had in ELSA. It's a general thing, the semi-parametric approach sometimes has some convergence issues due to some reasons, to some technical reasons. But still, overall, I guess we get a relatively consistent picture. For the HRS point estimates, we have one a little bit above 100%, one around a bit above 90%. For England, the point estimate of the parametric approach is 110%. For Germany, where we have the largest sample, the parametric and the semi-parametric approach are relatively similar, and we have values a bit below 100%. And in all cases, the identification bounds are around the point estimates, so the point estimates are not outside of the identification bounds, which would indicate that the point estimates might be problematic. That's not the case here. And the identification bounds are, especially for the US and England, more or less centered around 100%. For Germany, they are centered around the point estimates. Now, I said that the parametric approach and also the semi-parametric approach assume that the covariance term is 0, that there is no income dependence, which means that there is no utility dependence of the replacement rate. And I said that's a testable assumption. And here we see results of tests. I won't go into any details here how the tests work. But essentially, we have results for the US data, the English data, and the German data. And we have three types of tests: a parametric test, a semi-parametric test, and a non-parametric test. And a plus means that the test does not reject the null hypothesis that the covariance is 0. And a minus means that this null hypothesis is rejected. Now, looking at this table here, it's, I guess, fair to say that income dependence can be rejected. So income independence cannot be rejected. The covariance can be 0. The data is consistent with that, meaning that the point estimates should be more or less okayish. They are built on some other assumptions, some additional assumptions on top of income independence, which some of them are just not testable, so we don't know for sure that these estimates are reliable, but they don't look too bad compared with a non-parametric approach. And here in this figure, we added the replacement rates which people actually achieve in the countries. So this here, this cross, means that people retiring in the US achieve a replacement rate on average of around 100%. This is based actually on several studies. Some show results actually a bit above 100%, some show results a little bit below 100%. So this here is kind of an A-ball estimate. For England, the results, there are two results, both taken from the same study. This here is a low estimate, this is a high estimate, and people are probably somewhere in between. So when calculating what people actually get, it's also not super straightforward. You need to make some assumptions. And this is shown here. And for Germany, the number only includes the public pension. But in Germany, that's the most important source of income for retirees. So on average, people likely are not, don't have a much higher income during retirement. So comparing what people actually get with our numbers, we see that in the US, people are on average doing fine. But we also know for the US that there's quite some heterogeneity with respect to the replacement rate. And there probably is a sizable group which has quite a bit less than the level which we would call adequate. For England, well, depends which estimate we trust more, the low one or the high one. If we say, okay, the low one, then people today actually would be getting a little bit too less. If the high one is correct, then people on average are doing okay. And in Germany, as I said, it's only the public pension, but for most people that's the main or even only source of income during retirement, at least for recent cohorts of retirees. So for Germany, we actually might have a problem here. Now, everything I just showed you is based on many assumptions, and you probably don't like many of my assumptions. So we ran lots of sensitivity checks. We ran sensitivity checks for the main indicators, meaning the welfare indicator, the income concept, and the definition of retirement. So for instance, welfare indicator, I said we use the expenditure share of the income share of expenditure for food at home. Economists are most of the time happy with that, not all, but most. Sociologists usually don't like that, so we use other things. Then I said, when talking about the identification strategy, that given the standard assumptions, we can kind of identify everything. And one of the assumptions was unconfoundedness, so that there is no selection into retirement based on the replacement rate, but one can imagine that that's likely actually not true, that there is some selection. So we use instrumental variable strategy to deal with that. You might say, okay, only looking at singles is problematic. What about couples? Couples are actually the majority in the age range you look at. So we also ran analysis with couples. Those are in brackets because I won't show them here. We also calculated replacement rates by age, so we are not only looking at the age range from 60 to 69, but also at older ages. And again in brackets because I'm not showing that. And adding couples and replacement rates by age have an asterisk here, because if you look at the theoretical concept, the theoretical framework, slash the identification strategy, adding couples and calculating replacement rates by age might be somewhat problematic for some reason. Third thing fifth thing on this list which we did, but the third thing which I won't present here, estimation using subsets. So for instance, only looking at people, only looking at women or men and women separately, estimates by educational level, stuff like that. And I will show the sensitivity checks for the main variables, and will present the results, part of the results actually for the HRS. We used 5 different welfare indicators, so the expenditure share of food at home, expenditure share of food, and we have 2 measures of that, so that's 3 welfare indicators. A 4th welfare indicator is non-durable expenditure, and the 5th one is satisfaction with household income. And so the first 4 are kind of relatively similar, or looking at expenditure. But satisfaction with household income, that's a subjective variable. So individuals are asked, okay, how satisfied are you with your household income? And then they can answer on a scale of, if I recall it right, it was 1 to 10, but don't quote me on that. 10 meaning completely satisfied, 1 completely dissatisfied, not satisfied. We used 4 different income concepts one only using net income, second one net income plus annuitized non-housing wealth, third concept net income plus annuitized non-housing wealth plus annuitized housing wealth, and the fourth concept replaces annuitized housing wealth with imputed rent. And then we also use 4 variants of retirement status and use all possible combinations of these variables with the parametric and the semi-parametric approach, and that gives us 160 estimates of replacement rates. And yesterday evening calculations were still running. The semi-parametric approach is unfortunately pretty slow to estimate. That just takes some time. So here we see results based on 106 estimates. So x-axis is the replacement rate, the level of the replacement rate, and then we have a kernel density estimate. So the higher this curve, the more estimates are in a region. The vertical solid lines are the point estimates, so the parametric approach here and the semi-parametric approach here. And the dashed vertical lines are the set estimates, the identification bounds. And what we see is that we have this peak here, this very clear peak in the identification bounds. So there's some variability of estimates, that's to be expected, but most results are actually at least within the identification bounds. We have some pretty high results, but those are results based on the semi-parametric approach and non-durable expenditures, which are generally a bit weird. So the semi-parametric approach using that variable just creates sometimes outliers. Just does not seem to be very stable. And this smaller peak here, those are estimates based on the satisfaction variable. So if we use satisfaction instead of expenditure, we get lower estimates. And looking at the literature, that's actually to be expected. Satisfaction with income likely also is influenced with satisfaction in other life domains. And that might cause this replacement rate to be lower. So for instance, maybe people are less stressed because they don't need to work anymore, and that can just show in these subjective estimates. But so there is some variability, and subjective estimates are lower, but still the majority of estimates is within the identification bounds. So I guess that's fine. And when we use an instrumental variable strategy to deal with endogeneity, I won't explain this, I just skip to the results. We can only use this strategy with the parametric approach due to some technical reasons. But then we get these estimates here, these blue ones, and they're pretty close to the estimates of the parametric approach using the retirement dummy. So endogeneity likely is not a big issue. So to summarize, we study the net replacement rate, which is needed to maintain the living standard achieved during working life in retirement, where we look at net replacement rates defined as net retirement income divided by net pre-retirement income. We propose this as a standard for pension adequacy, and the main contribution is that we present methods to estimate this quantity. Our main findings show that in the US, England, and Germany, the adequate net replacement rate is around 100%, plus minus 10%, maybe plus minus a bit more. You've seen that there is some variability in results. Compared with what people actually get, retirement incomes might be too low in Germany, and for the US and England, where right now people might be doing okay. But if we look at projections of retirement incomes, those are projected to decrease in the future. So people in the US and England might have too low retirement incomes in the future. As you probably guessed from what I told you, this project is of course still work in progress and many things unfinished, especially the sensitivity checks. I only mentioned several things briefly and in a superficial way, especially income dependence / independence. And there are many open questions which I guess follow naturally when you start thinking about this. For instance, the dependence of replacement rates on health, right? So one can imagine that if you are in bad health, then you might need a higher replacement rate. But so far we haven't looked at that. So I guess that's it. Thank you very much for your attention.